Here we go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. And you're seeing there on your screen our first Earth views. This view of Earth captured from a human-rated spacecraft not seen since 1972 during the final Apollo mission some 50 years ago. The views of our blue marble in the blackness of space now capturing the imagination of a new generation, the Artemis generation. At 6:44 a.m. Central, just about 9 minutes and 30 seconds ago, commands were sent for the outbound powered flyby burn to occur with the Orbital Maneuvering System engine, or OMS engine, on board Orion, which sends Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for 1/2 elliptical orbit around the moon, which will last about 6 days.
Now to distant retrograde orbit, or DRO. We're going to be about 38,000 miles away from the lunar surface as we orbit around. That's part of why we're calling it distant. And we call it retrograde because the moon orbiting the Earth in this direction, and then we're entering into our orbit in this direction. Opposites, retrograde. Now we're choosing this orbit because it's extremely stable. It doesn't cost a lot of fuel to maintain your position there, and that gives all of our engineers, our flight controllers, the chance to really learn about Orion systems in deep space. We'll learn about flying a spacecraft farther than we've ever sent one intended for humans. We're going beyond anywhere we ever went for Apollo. And so we're in that orbit, test out all of those systems. Eventually we'll do a maneuver to break out of that, do another flyby and come home.